Hi, everybody, and welcome to today's webinar on designing smart cities. My name is Kelly, and I'll be the moderator for today's webinar. I am joined by Milton Malva, sales engineer here at IBWave, and Claudio Rosa, IoT engineer from Nazondas Technology. We've got a really great webinar for you today. It highlights a real use case of designing a LoRa network for a smart city application. We hope you find it really interesting. Before we get started, I'm just going to go over a couple of housekeeping items here. We are recording today's webinar, so you will receive a recording of the webinar after we are done here. And then feel free to ask any questions that you have as we go using the GoToWebinar questions box, and we'll do our best to get to it towards the end of the webinar. So thanks very much for joining us. And at this point, I'm going to hand it over to Milton to get started.
Okay, thank you, Kelly. Hello, everybody. I'm here with Claudio Rosa. We are based in Brazil, and we will present this webinar to you. I'm sales engineer in IBWave. Claudio is the IoT engineer and working in this real case here. Hello, Claudio, how are you?
Oh, how are you? It's a pleasure to be here.
Okay, thank you. We prepared an agenda today talking a little bit about smart cities overview. So we will talk about some definitions, concepts, technology and applications, and the main challenge to create a smart city design. And then we will be focusing the use case that Claudio worked in Rio. He worked in this challenge for the Rio Operation Center, looking for how to manage the integration of infrastructure, logistics, and urban emergencies. And then we will talk a little bit about the conclusions and lessons learned during this journey, and in the end, we will have some time to questions and answers. Let's start with some smart cities overview. And when we talk about smart cities, smart cities is a concept that started in 1950 or 60, and of course the concept of the smart city has changed during these years. But basically, by definition, a smart city is a technologically modern urban area that use different types of electronic methods, voice activation methods, and sensors to collect specific data. And this information gained from that data is used to manage assets, resources, and services efficiently to improve operations across the city. Of course, in the actual days with the Internet of Things, it's pretty easier, right, to have more sensory and monitoring options. And the amount of data includes data collected from citizens, devices, buildings, assets, and all this data is processed and analyzed to monitor and manage different applications in different areas of the city, right? For this reason here, we can see that we can divide the different applications, different areas, such like smart home buildings, smart health, smart education, smart water and energy, smart governance, mobility, agriculture, retail, and the others. Here we just have some samples, right? Our presentation will be focused in the smart governance because we will talk about emergency risk areas, right? So when we talk about the different technologies and applications that we can use in smart cities, of course, we rely heavily on deployment of different combinations of technological infrastructure and different types of applications and technologies with varying levels of interaction between human and technological systems, right? Along the IoT solutions, smart cities also include and use different technologies. So for example, when we talk about the digital information that we have, we need to have a service-oriented infrastructure required to connect individuals and devices in a smart city, right? So we are talking about application programming interfaces, end-to-end communications, and with these different applications, we will collect a lot of information. So we need to have some intelligent and cognitive technologies such as artificial intelligence and machine learning that can be training on the data generated by Connect Cities in order to identify patterns, in order to process the information. And of course, we are talking about cloud and computing services. And in order to have the operation or to make the solution operational, we need to work with mesh networks in order to provide the different networks, right? So we can work with different technologies looking for the network perspective. And of course, we are talking about a lot of data, so we need to have applications such as blockchain, big data, and of course, we are talking about security protocols and wireless sensors network. So around the smart city, we had a lot of technology and applications that we need to use and apply in the smart city. And in order to do that, we have some challenges, right? So when we look for the challenge, we can separate the smart city or the implementation or the planning of the smart city in 4 different steps, right, or different phases, right, to improve the quality of life of the citizens and enable economic growth through the network of the connected IoT devices and or technologies. So these 4 steps are the collection phase is the first phase, right? So here is where we work with smart sensors to gather real date time, right? Then we will have the analysis phase, the second phase, the analysis phase. Here we will have the entire data, and we need to analyze to gain insights into the operation of the city services and the operations. And the results of these data analysis must to be communicated to the decision makers, right? So you have the 30 step that will be the communication phase, and the 4th one is the action phase, right? So since the decision makers have the entire data analysis, they need to decide and take into improve operations and decide the actions that must to be done and manage the assets and improve the quality. So here we have a lot of different actions that can be done. So for each step, we have different challenges, right? When we talk about collection, we are talking about different types of sensors. Of course, we need to have or need to think about the power consumption, right? So we need to think about what type of sensor we will need to use, what regarding the different technologies that we are using, and the reliability, right? So we need to have accuracy in the information. When we move to the analysis phase, we are talking about a lot of information, so we need to have some intelligent data analytics because we are talking about heterogeneous data, right? So talking about heterogeneous data, we need to have this intelligence to do it fast and thinking about scalability, right? So we need to think that we will improve the solution, or we will try to apply the solution in the entire city and maybe do the same in another cities. And after the analysis, we need to go to the communication. So we need to leave the decision makers receive the information. So here we need, of course, to think about security and privacy of the information, but you need to think about the access control, about the data leakage. So we need to avoid the data leakage, and thinking about the access control, we need to think about the interfaces that the decision makers will have, how they will get the information, how they will make the decisions, and then they will move to the action phase. And of course, here again, they need to have the networking, they need to have access to the entire information, they need to decide how to make the operation better, how to improve the operation, and the most important, how to leave the final benefits to the citizens, right? So this is the most important thing in the smart city. So in this phase, they need to guarantee the quality of the services, of the resources uses, and the investments application. So they need to look in the entire overview of the action and the operation of the smart cities. Talking about the use case that we will present a real use case that Claudio is working in Rio de Janeiro, here in Brazil. And the Rio de Janeiro city, or the Rio de Janeiro Operational Center, in 2018 started with the AeroC Challenge. So the AeroC Challenge is a project that the Operational Center developed to challenge new startups or new companies, or even interested technical groups, to improve their performance in managing the integration of infrastructure, logistics, and urban emergencies. So they started this challenge exactly to bring new ideas, new innovation solutions to the operations in order to get a real a smart city, right? So the first edition, they started with the challenge of developing solutions that help the operational center to increase the performance in managing several rainfall events in the city. So they work in very specific challenges, right? In the second edition, they started in 2019. The challenge was to create solutions that allow the operational center to more efficiently manage the impacts of climate change on the municipal bus system. So here they are, in this second issue, they are looking for a very specific application for the municipal bus system. And in 2021, they launched the third edition, and in this edition, they preferred to detail a little bit more the challenge, right? So in this third edition, the main objective is to work in the emergency situations, right, in different regions of the city. But they divided this new challenge in 5 detailed challenges. The first one was to how to improve the effectiveness of channels, or the content of the communication sent to the population in urban emergency situations. So here, if you have an emergency situation, how they can improve the efficiency to communicate the people about this emergency situation. And then how they can measure in real time the effectiveness of the communication that they are sending to the people in the urban areas, right? So the second one was the communication effectiveness. The challenge 3 was since they have an emergency, they will start to launch the alerts, right? The automatic alerts. So how to structure and the automatic alerts, and in two different ways, right? How the people will receive the automatic alerts in the post on the social media of the operational center, and the second one is the data coming from the application, right? So the third one is how to structure better the automatic alerts and the citizens receiving the alerts, right? The fourth one was how to structure the sending of automatic alerts to the citizens through urban sensors data. So since they are monitoring the emergency areas using sensors, how to use this real data and make these come like alerts to the citizens. And the 51, how to reach the disconnected population or those with difficult access to the internet, right? So when we're talking about urban emergency areas, we are talking sometimes in a poor area or more suburban area, right? So in many cases, the people that live there don't have any internet access, right? So how to reach these people, how to attend these disconnected people. And then basically in the challenge, the first phase is the inscription phase, right? So all these companies and startups can place his inscription or their inscription, and the second phase is exactly the analysis of the inscriptions and select from the inscriptions 10 finalists. So these involved a jury that decide what is the 10 finalists, and then another detailed judgment will decide between the 10 finalists what will move to the third phase. The third phase is the pitch day. So they select 4 from the 10 finalists. They select 4 for the pitch day to present the solution, and then they have a more technical team that they involve a lot of persons and agents from the city government and different areas, and they in the 4 finalists have the pitch day to present the solution, to present the value proposition, and they must present the minimum value product, right? Exactly to move to the trial. So in this third phase, they can select the 4 or 1 or 2, and then they can decide which one will move to the trial phase. So to the trial phase to put in operational or make it operational as a trial to prove that the entire solution will work and how we will work, and of course validate the entire proposal, right? So if they have success, they will receive the certification, and receiving the certification, they move to the last phase, that is the incubation phase. In the incubation phase, they will have up to 2 years to implement the solution, to get the investments and to make it operational, and then start to implement in the entire city and make it operational, right? So in the presentation, Claudio will show you how he presented the pitch day. So how is the idea, or how is his solution, right? How the solution presented, and of course the pitch day, and he will finish with the most interesting for me, that is the real case. So he will show you the trial that he installed it and how it's working, and he will show some real data measurements. So it will be very interesting. I will make you presenter, Claudio.
Important thing, Milton, could you back a little bit? I mean, for the previous slides, just to do a quick comment, could be.
Sorry.
Sorry, put my in silence mode because everybody is calling me in the middle of the in the webinar. This is the real life. Sorry about that. I mean,
this one.
Could you back to the previous slides? I mean,
this one.
No, I'm not seeing your slide, your screen.
Can't you see my screen?
No, I'm just seeing seeing the major screen. I mean, Design Smart City.
I'm presenting my screen. Yeah.
Now I'm seeing. Okay, sorry, I was on the
Okay.
wrong screen.
This one, Claudio? Yeah.
No, the phase slides, because
The phase.
important things to mention it is that everything that I will show from now, it is related with the phase that the Milton is describing. Why? Because the phase is showing or is talking about the problem that the city has today and what kind of solution we are addressing one by one. No, but it's the phase one by one, by the 5 phases and the challenges and the last slide,
Oh, the challenge of the
Yeah, exactly.
this one.
Yes, exactly, this one. Because let me give an example before I begin exactly. When we talking about efficient improvement, what's the real meaning about that? I mean, today we have a siren to 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 advise everybody that we have an emergency and situation about something, rain or something about that, or a sliding or something about that. But nobody knows who is listening, who heard the sound, that the siren. And the one of the solution that we are addressing is related about that. I mean, one by one, we are talking about with you what kind of solution we are addressing for each challenge. Okay, this is one important thing, because I mean, this is a very important slide, because this is the beginning of all the history. Okay. Okay, see my screen?
Yes.
Okay, thank you. This is the name of the group is just to make a joke or a small, just kidding. I mean, I was thinking about Michael Jackson, "Don't Stop Until You Get Enough," because this is the real situation that we have when you try to do innovation. And because a lot of people will say to you, "Oh, this will not work," but don't stop, go ahead, and we'll make it happen. Okay. And how the history begins with a small history that we create, just to try to exemplify some situation that we have here in the Rio. We have two different regions, and one of them we have flooding problems, and the other one we have sliding. And we create a fictional situation when you have two peoples that live in different areas but with different problems. And after that, after our solution, they can sleep a good dreams, because now they know that someone's take care of them. And this is the real situation that we have. And let's see what we have. Sorry. Yeah, as Milton said, our challenger was split in 5 challengers, and of 5 of them, in 4 of them, we can give or we can address a solution. In the middle of our solution, we have a smart pole. We call it EcoSite. And this is a urban solution, and we can install anywhere in the middle of the city or country, or for transportation, industry, no matter. We can, in the end of the day, this solution I will describe a little bit more in details in the next slide, but this is a hosting solution. Instead of, you can say that this is this is a town data center, because in the end of the day, this is a place to put your solution inside of the pole, because we have treatment for all environmental questions or problems. I mean, temperature, humidity, and pressure, and everything that we have treatment for this inside of this pole. I will show you how. Show. And this is the reason that we call it simulation, because we propose one thing that will prove soon what kind of thing we are proposing, okay? And the first proposition was related with, okay, how to have access for the data that we are measuring. This is the first challenge that we have, and we create a good image. This is Copacabana Beach, and we have, I mean, this is not a real application, but just to give it an image, a good image to have at the beginning of the system. And what this system can provide to you, it is information about, for example, a weather station. The weather station is not the only one, but this is the first solution that we developed, and this is the more stable solution that we have, because they're working for more than 2 years, okay? And it's very important to describe a little bit the value proposition that we have, because in fact we are developing an open solution no matter what kind of vendor we are talking about, because we have a global standardization. We have a solution that we can put together, because all the components that we have in the solution belongs to standardization. I mean, LoRa Alliance. This is the kind of the standard that we decided to use. I'm a certified LoRa engineer, and I mean, I did this kind of decision because this is for public infrastructure. This is excellent kind of solution that you can say, hey, you can put everything that you want. Sure, if you have a standardization, no matter what kind of, but if your vendor belongs to a LoRa Alliance, will work. Don't worry about that, okay? And we have a great evolution capacity, capillarity, scalability, modularity, because I mean, you can begin very small, and we can go, or you can grow to an entire city. No problem. You can every time you can be in your comfort zone. Don't worry about that using this kind of solution. And other very important things to describe it is related that okay, if you wanna, I used to say that LoRa is very similar that we have in the Wi-Fi, and we have a Wi-Fi Alliance, we have a LoRa Alliance, and all this organization is no profits organization that the idea is less developing standards to be able to apply in every country, every place that we have. And no matter if you can do a private network using Wi-Fi, or you can create a public network with Wi-Fi. The same thing for LoRa. You have I mean, huge providers here in Brazil for entire, I mean, more than 200 cities in Brazil. I mean, providers that you can pay for that, or if you want to develop your own private network, no problem, you can do it. And this is the and you can have a hybrid, a mix of them, no problem, okay? And this is an open source. I mean, open source is not much. Many times we can and some people understand that open source is for free. No, it's not for free. The open source, in the end of the day, it is okay. The thing that you can do yourself, or you can develop something for something that already exists, and no matter. You can do it, and you don't have to pay for that, because it's no license requirement for that. And we have a strong immunity for interference. This because this kind of solution, not exactly a new solution, but it's an old and stable solution that we can use in huge networks. The number of the things that you can measure, it is amazing. I mean, this is just a list. I will not read it one by one, because this is, I mean, in our weather station we have, if I'm not wrong, 6 or 7 sensors of that. But you can do it for a slide that you have geo sensors and all this kind of thing that I will describe in details a little bit more ahead. Okay. And for our study, we developed two solutions. One for flooding in this area. I don't know who knows the Rio de Janeiro, but this is Rio de Janeiro. I live a little bit left here from here, but very near to where I live, we have a community here where you have a lot of flooding problem. Why? Because they are in the same level of this lake. Now, this is a lagoon. Sorry, it's not a lake, a lagoon. And if you have a high tide or rain or anything, this could you become a flood. This is the process that a lot of people. I mean, this time of the year, I mean, the summer is the worst time for exactly this problem because we have a lot of storms, and this is one of the things that cause the flood. But this is not the only one. As I said, they are in the same level. And if you have a high tide here, this is the ocean. This is a Barra da Tijuca beach, and you don't need too much things to have a flooding process here. Okay. And the other thing it is related to Vidigal. This is the second area. This is a sliding. This white mark that we have in the middle of the green here. It was a sliding problem that had here, and a bus was under all this ground, and people died in this kind of problem. And this is not exactly a simulation because at the end of the day, 3 years ago, all this region was blocked because of this problem that happened. In more than a year, they did a lot of things to back to the normal. Okay, and just to give it details, this is the why I'm describing, because as I'm describing here, we are in the lake, in the lagoon. Sorry, in the lagoon. This in the real. This is the real situation. And the same thing with Vidigal. This is another thing that this is like problems that we have here. And how give treatment for this kind of thing? I mean, I'm talking about two different problems, and the major problem that I need to address a solution is, okay, I need to take care of the people. I need to save life. I need to take the people out of this kind of risk. And how to give solution for all of this kind of things. And for this one, in fact, the tools that we used, it had a strong responsibility to give the right solution. One of them, it is IBWave Reach, is a tool, radio frequency tool, to design it to create solution to have coverage to quality for wireless network. In my case, LoRa, but you can do it the same thing for 4G, for 5G, no matter. Okay, and other important thing is our solution is based on a smart pole called the EchoSight. And where is the right position for my smart pole? And a smart pole, we are talking about 18 meters and 1.5 kilos, huh? And it's not exactly a easy mistake. No, I cannot do a mistakes here. Okay, and this smart pole is, as I said, where in this smart pole I can do it as I can work with them as a hosting solution. Why? Because I can put it or can install inside of this one a lot of gateways, radio stations for 4Gs, TV solutions, batteries, and other things. All this solution have environmental treatment for them. I mean, temperature, humidity, air pressure, and air quality. All these kind of things. We are using IoT to measure it to say, hey, it's okay. Oh no, it's not okay. We have a dirty filter, air filter, for example. It's time to change it. and this kind of thing that we know. Yeah? And at the end of the day, this smart pole is one of the center of our solution, because the antennas for the LoRa Gator, for example, in our case, is responsible to spread the signal for all of them. I mean, the sirens, the weather station, personal trackers. This is a button for tracking. This is a badge for with panic button. Micrometers. I mean, water and electricity. Trackers for fleets and geosensors. This one, but this is not alone. If you want, you can do public lights too. Okay. But one smart solution is a very simple. This is one thing that I used to say, that I mean, not all smart solution should cost a lot. This is a very cheap solution. This is a smart button. In fact, there are 4 buttons in just one box to say, hey, when we have a sound of siren, not silent, siren. The first button, I mean number 1, begins to flash, asking you, did you heard this the siren sound? When you press the number 1, you are saying to the operation center, hey, I heard that. And for example, if you have 50 of these buttons spread for the community, you know how many people listen to the emergency signal. This is the beginning of the flow that we are trying to develop. But it's very important, because today, when I push the button to play the siren, nobody knows how many people listen to this one. This is the problem. But when you push the button, the first button, the second button begins to flash, asking to you, hey, did you leave your house to go to the safe place? When you push the second button, say, hey, okay, I'm away. Okay. The third one, yes, asking to you, did you reach the safety place? This is a very basic solution, very cheap solution, but you can save lives doing this kind of things. And the people in charge to give help for the people in the city will know, okay, I don't need to send any kind of rescue team for there, because everybody is saved. Everybody answered with the button. They say, okay, everybody's in the safe place, no better. But if you cannot go to the safe place with the third button, you can push the fourth button or the panic button to do another solution. Say, okay, I'm aware of all of this, but I'm using wheelchair, and I cannot move myself because it's raining. I don't have a good road to go until the safe place, and I need to be rescued. And this time, the civil defense here will send a team, a rescue team, for a real situation that these people, I mean, Claudio, is asking for help, and now they know that. Okay, I spend a little bit more time about this kind of description, because this is kind of description that say, hey, this is a smart solution, but at the same time, this is a very cheap. You don't need to spend $1 million to develop a smart solution. No, you can do a very cheap solution doing this kind of things. But flooding is not exactly the only problem. We have sliding. This is a completely different kind of problem, but at the same time, we have a team to give a right answer for that. This is the reason that we did a partnership with another company called World Sensing. This is a Spanish company. They are geologists at the end of the day, and they are using a lot of networks to create solution for mining companies, for city they have slide problems and other kind of things. And this is the reason I'm a mechanical engineer. I cannot doing solution for a slope or something like this kind of problems, because I cannot do it. This is the reason that we have a partnership with different kind of company, one by one, with your kind of specialties. Okay. And they have data loggers and sensors able to describe exactly what is the situation. If you have a separation between two parts of the same mountain, but we are having a cracking, and we need to evacuate everybody because probably we will have soon a sliding problem over there. And this is kind of thing that this kind of solution, we are because at the end of the day, the message is, okay, no matter what kind of problem, we have some kind of specialists to give a solution for you. This is a heterogeneous solution, but in the end of the day, it is a homogeneous solution because all the solutions are based on the same LoRa network. Okay. And to give the answer for all these kind of questions, we use IBWave Reach to give the exact position for all smart pole that we need to put. This is the Rio das Pedras location, and this is a Vidigal location. For this one, we have two smart poles, having 100% of redundance of the coverage of this one. If you have a complete fail one of them, the other will be able to answer for all functions that we need to develop. And the same thing will be for sliding here. Then this is for Vidigal. Okay. And I don't know who know, but this is a wonderful, software and tool based on georeference process that I work in the team that in the beginning 2 years ago to try to test this kind of thing. It's an amazing tool. Okay. And this is a resume for this kind of thing that we have. I mean, Rio das Pedras and Vidigal. And now I would like to share with you the real case, because when we pass all the things, we go to the real phase. Let's test this kind of thing in an MVP. MVP is a minimum viable product. Okay. And what we developed another solution for a floating area, okay, called the Jardim Maravilha, or Marvelous Garden, if you can say this way. But I mean, this is a solution that you have a area, I mean, below the ocean level, and I will see how in this small video here. Just go ahead. The entire area it is sorry. Okay, it's side by side two rivers, one here or that, but all this hand is showing exactly what the entire area that we need to cover. But as I said, the ocean is very near. This is here, and we have a high tide or something like this. Same problem for that we have in Rio das Pedras. This is a problem to drain all this water that we, because this is we have a different kind of level here from I mean the right to the left, and all this water will be reached here in Jardim Maravilha. This is a nightmare because we need to do a lot of things to make advice to people that live in here to say, hey, you need to go to the safe place because the water is coming in the river. Okay, and we put here at the weather station and the LoRa gateway here in the school, and we show in the next slide how we will do. But here you see that how we can mark and develop a solution for a specific point where we need to install this water level meter. Let's see another one. Sorry. Here, sorry. No. Sorry about that. Okay. There are two pictures about the what we have here. In the top of this school that we have here in the middle of the Jardim Maravilha. Here's the weather station. This is a gateway. All of them, they are autonomous systems. We have a power provided by solar panels, and we can do everything without any kind of contribution and solution. As we don't have a physical infrastructure as fiber or copper, or Ethernet cable or something like this. This kind of gateway using a 4G SIM card here, and I maybe it's not too near to be seen, but we have a tower here. But all this gateway using 4G as a backhaul. Okay. Okay, sorry about that. Que já foi. Sorry. Okay, next one. Okay, let's see how all this kind of thing was measured in the iWave reach. Let's see. This is the same area. We import the map from the Google Earth Pro here, and as you see, we have all the same elements that we have in the map. We bring here to the reach, and in the reach we can install the same infrastructures or recreate. We have a gateway 12 meters above the ground, and using a omnidirectional antenna. And what kind of coverage this solution is given to us? This is the thing that the reach will help us to calculate. Okay, we showed all the mark points that we have in red here, this one, to try to track the water path here, and we can create two maps describing the signal strength and the spreading factor for LoRa, to say, hey, this is a good or bad solution for us. And as we can see here, sorry, oh my God, sorry, let me stop here. Okay, let me stop here. As you can see here in the legend here, you're gonna see that LoRa can work until minus 125 here is able. But when the end of the day, where you need to pay attention is to the sensor. What kind of sensibility that we have for the sensor. But we can consider as minus 110. It is enough to say, hey, most of the people, most of the sensors will be able to work in the yellow or above. Okay, and as you can see, we have here, and here, and all of them, the reach will say to us, but the color, you can say, hey, they are here in this zone, all this kind of things in this zone, above yellow and above. And then I'll say, okay, probably you will work. Let's see if this kind of solution will work or not. Why? How? Sorry. In ValueCell. In ValueCell, we can put in the place you're gonna see. Take a look. Minus 66. Okay, it's perfect. Minus 74. The other one. 78. Oh, that's one. 98. Perfect. Perfect. It will work without any kind of problem. Sure. This is a very, basic analysis because sorry about that. Because in this analysis, we are not accounting about some kind of thing that call it clusters. They are buildings and other kind of thing. This is just a basic analysis. But based on this analysis, we'll be able to work with this kind of thing with the water level sensors, all this one. Okay. This is a very important thing that we can use to guarantee that our money is going to the right direction. Okay. This now I'd like to share the really real kind of an analysis, because I'm doing weather prevision here to the Rio de Janeiro. Let me show with you. And now you're seeing the real situation. This is Rio de Janeiro city. Here it is Rio de Janeiro state, because we have both with the same name, but here they are different cities. Now we are seeing the map of the radar Doppler. This is a weather radar, and they're saying, hey, in this area you have a lot of problems here because we have a storm here. But this is another state. This is it's Minas Gerais. But you have a cloud from Minas Gerais until Rio, until Rio. Near to the Rio de Janeiro city. Now they are reaching Duque de Caxias. But this is what kind of things. But this is a problem or not? Okay, let's see in the weather station if this kind of picture that we are seeing, right? This way. This is a problem to the Rio. Maybe or maybe not. Let's see. This is the north. This is the north here. Why I'm saying this is why is it important to know the direction? Why? Because I need to pay attention about the wind direction. Okay. Now we have a southwest direction. 208 degrees in the wind direction. Okay, and the wind is not too strong, 43 kilometers per hour, and the pressure is a little bit high, not so much, but it's high, to avoid storms here. And as I see, in the end of the day, it's normal to humidity to grow a little bit, but we have not too high, but it's high humidity, but the pressure is high, and the wind is not strong. This is the reason to say, hey, not for now. Maybe we're gonna have rain at night or late in the night, not in the beginning of the night, because all this information can say, hey, if you have a wind from the north, but I have wind from the south west. This is the reason that say, okay, I have problems in the southwest. No, sorry. No, southwest is clear. Here. Southwest is the ocean here. This is north. This is southeast, southwest. And okay, but I don't have a wind comes from the north. This is the reason that I can say, hey, probably we don't have storm comes from the north because the wind is not taking this direction. Okay, and this is it. This is the kind of way to that we have to helping people that live here in this region to say, hey, we can sleep well this night because you're not having a storm this night, or oh no, this is probably you need to pay attention this night because this is the reason, and this is the way that we are doing this kind of taking care of these people that live here in the Rio. Okay, this is it, Milton. I'd like to hear your questions and comments. Okay.
Yeah. Thanks, Claudio. Just to finish, as you could see, guys, Claudio showed the real-time measurements, right? The that's running right now in the that's running right now there in Jardim Maravilha, and based in this final trial installation, Claudio finally got the certification. So he will receive the certification tomorrow, right, Claudio?
Yeah.
In the operational center, and of course we just finished with some conclusions here. When we talk about the smart city, guys, we are talking about the cities, those that make the citizens happy, right? So it's very important to look to the citizens in the end, and you cannot be happy if you don't have access to the minimum health, education, safety, sanitation, and more, right? So it's very important to look to them, and the innovation solutions will bring these options to the cities. And how the smart cities involve public investments is very important to have. Cost effectiveness is one of the main criteria, right, to move or not to or to the next phase, or make or not the new solutions viable or not, right? So for this reason, it's very important to use some tools like IBWave Reach, because with IBWave Reach, you can validate the KPIs of the network, right? Claudio showed to us some sample to a lower system, but we can have, and we can make in design using IBWave Reach, such as LTE, 5G, and the other technologies, and we can validate, right, the coverage, the quality, capacity analysis, and all these parameters are mandatory to guarantee the network performance, right? So so we can guarantee to the city that the investment will be used in a good way, and we'll guarantee that they can implement and have more scalability, right? So and have a good usage of the investments. And just to finish, we think that the initiatives like this one, there's a core challenge, real, are very important, right, to develop innovation solutions. So you could see here just an idea that started with Claudio, right, with his solution. Right now, he has one trial installed running in Jardim Maravilha. He could show that they can have a real measurement and make sure that they will have or not an emergency situation there. In the next phase, Claudio will implement the other things, right? The button and everything that he showed to us. But it's very important to say that these initiatives can bring innovation solutions, and this challenge, or this core challenge is not for real right now. This year they had or they are doing in partnership with the city of Cologne in Germany, right? So we think that different cities can start to have this type of initiatives to start to have more innovation, and of course become the cities more smart, right? It's the content that we want to show to you. I think that we have some time for the questions. Kelly?
We just have one here, actually, Milton. It's around the Helium network, and have they considered joining the Helium LoRaWAN as part of the project?
Excuse me.
Claudio,
Okay. Sorry.
I mean, if you're familiar with the Helium network, the question was, have they considered joining the Helium LoRaWAN as part of this project or utilizing it?
No. What is Helium? Okay. Sorry.
Yeah.
Sorry. Helium. Oh, sure. Yes. Could you repeat the question, please?
Yeah. Yeah. Had they considered joining the Helium LoRaWAN, which is a public network? So
yeah. Okay.
This was the question. I don't know if it makes sense, but that's the question.
I mean, the Helium implementation is LoRa. Yes, it's LoRa. But I have some questions. I have some questions about Helium, because Helium is LoRa, but it's not exactly LoRa WAN Alliance standards. And this is why, because Healing, the idea of healing is to say, who is my neighborhood? This is the idea of healing. Who is near to me? And this is not exactly the thing that, because I mean, the Halo network was created to find who is next to me. You can do it, this kind of things using LoRa. Yes, you can do it. But I'm curious to understand what will be the evolution for Helium, because they are using Helium to do something that LoRa can do, but not exactly the same kind of topology and standard that Helium is doing. Okay, I'm not saying I'm against Helium. No.
Yeah.
I'm just curious to say, hey, it's funny. They found another kind of way to using LoRa networks, but I don't know how compliance with the standard Helium network will be able to maintain in this evolution track. This is one kind of thing that I'm following with curiosity. Okay.
Yeah, makes sense. Thank you very much. Okay, since we are at the top of the hour and I don't want to keep people, we will have to conclude the webinar here. So a big thank you to you, Claudio, for joining us, to everyone in the audience who joined us today, and of course to you as well, Milton. Thanks everyone, and I hope you have a good day and enjoyed the webinar. Take care.
Okay, it was my pleasure. Thank you.
Thank you. Bye-bye.
Bye-bye.